For nearly 5 decades, Voyager 1 has been humanity's farthest-reaching envoy, a quiet hero of cosmic exploration launched in 1977 by NASA's Jet Propulsion Laboratory, JPL. This unassuming spacecraft, originally designed for a 5-year mission to study Jupiter and Saturn, defied all expectations, venturing beyond the planets, past the heliopause, the boundary where the sun's influence wanes, and into the uncharted depths of interstellar space. Carrying a golden record etched with humanity's greetings, Voyager 1 became a symbol of our insatiable curiosity, whispering back data from distances unimaginable over 15 billion miles from Earth. Its nuclear-powered systems, though aging, continued to transmit faint signals across the void, outliving predictions and surpassing engineering limits. By 2025, it remains the most distant human-made object, a testament to ambition and resilience. Yet, in late 2024, something changed. After months of eerie silence, Voyager 1 came back online, but the message it carried wasn't the familiar stream of scientific data. Instead, it delivered something unsettling, a low-frequency hum, gravitational anomalies, and readings that suggested the edge of our solar system is not the empty frontier we imagined. This is no mere anomaly, it's a revelation that challenges our understanding of the cosmos. Voyager 1, once a beacon of discovery, now floats as a messenger bearing warnings from the unknown. What follows is an exploration of its journey, the disturbing data it returned, and the questions that now haunt us. Is the darkness beyond our solar system truly empty, or has Voyager crossed a threshold we were never meant to approach? The silence and the signal. In October 2024, JPL engineers noticed a troubling shift. Voyager 1's data, once a steady flow of measurements from its cosmic ray, plasma wave, and magnetic field instruments, had become incomprehensible, garbled noise replacing coherent streams. The spacecraft's flight data system, its memory and processing core, appeared to have malfunctioned. For 5 months, NASA grappled with uncertainty, sending commands across 15 billion miles, each round-trip communication enduring a grueling 45-hour delay, 22.5 hours to reach the probe, another 22.5 for a response. The effort was delicate, like whispering to a fading friend across an abyss. Engineers recalibrated systems, rerouted power, and scoured decades-old manuals for solutions, all while the public remained largely unaware of the crisis. Then, on March 20th, 2025, a breakthrough. Voyager 1 responded, not with a mere carrier signal, but with data. The JPL team erupted in celebration, hailing the revival as a triumph of engineering. Yet, as they decoded the fragments, elation turned to unease. The spacecraft was stable, its instruments functional, but the environment it described was unlike anything anticipated. The heliopause, long thought to be a gentle transition into interstellar space, emerged as a chaotic barrier, a turbulent wall of plasma pressure spikes, radiation bursts, and magnetic distortions far more violent than any model predicted. This wasn't a fading gradient, it was a storm, a region where the rules of physics seemed to bend and snap. More chilling were the density measurements. Voyager's instruments recorded massive fluctuations in particle density, so intense they suggested something was compressing the space around the probe. The data revealed an oscillation, a rhythmic pulse like a heartbeat reverberating through the void. This wasn't random noise or instrument error, it was consistent, mapped across multiple sensors, and grew stronger as Voyager drifted deeper. The edge of our solar system, it seemed, was not a passive boundary, but a dynamic, reactive zone, perhaps even aware of the intruder in its midst. The haunting hum buried within the re-established data was an anomaly that defied explanation, a narrow band signal, low frequency, continuous, and eerily regular at 3 kilohertz. This hum, detected faintly years earlier and dismissed as background noise, now emerged with startling clarity. Unlike natural plasma wave oscillations, which fluctuate with solar activity, this signal was constant, unaffected by electromagnetic storms or radiation. It was not a traditional transmission, no message, no modulation, but its uniformity was unnerving, like a ticking clock embedded in the fabric of space. As Voyager pushed deeper into a specific sector of interstellar space, the signal grew not in volume but in definition, as if tuned to the probe's presence. Within JPL, debates erupted. Some posited it as a natural phenomenon, perhaps a plasma resonance unique to the interstellar medium. Others, however, noted its structured nature, its refusal to waver under external influences. This wasn't just noise, it was a pattern, a signature. The question no one dared voice aloud began to surface. What if Voyager wasn't merely detecting a signal? What if something out there was emitting it? The implications were staggering. For decades, we've scanned the cosmos for signs of extraterrestrial intelligence, from SETI's radio telescopes to the Breakthrough Listen initiative. Yet, here was Voyager 1, an aging probe never designed for such a task, stumbling upon a signal that defied natural explanation. In 2025, with advancements in AI-driven signal processing and quantum computing, JPL's analysts could enhance the data, isolating the 3 kilohertz hum with unprecedented precision. The results were undeniable. The signal had been present for years, growing clearer as Voyager approached an unseen point. Was it a cosmic coincidence, or had the probe crossed into a domain where space itself responded? A gravitational enigma. The final piece of the puzzle was perhaps the most unsettling. Voyager 1 was drifting, not due to propulsion failure or hardware degradation, but from an external force. Trajectory calculations, when compared to earlier projections, revealed a slow but undeniable deviation. Something was exerting a gravitational pull on the probe, subtle yet consistent, drawing it toward a region devoid of stars, planets, or known celestial bodies. NASA aimed its most advanced instruments, space-based observatories like the James Webb Space Telescope, deep radio arrays like the Square Kilometer Array, toward the coordinates. They found nothing, no light, no heat, no mass signature, only darkness. Hypotheses abounded. Could it be a rogue planet, a wandering black hole, or a dense cluster of dark matter? None fully explained the data. A black hole would produce detectable radiation, a planet would reflect light. Dark matter, while invisible, lacks the concentrated pull observed. The anomaly wasn't a gravitational well, it was a directed force, as if Voyager were being guided. The plasma storms, the 3 kilohertz signal, the gravitational tug, they converged on a single terrifying possibility. The edge of our solar system was not a boundary, but a threshold, a line where the universe's rules shifted. Earth's response. Silence and speculation. As Voyager's anomalies made waves within the scientific community, a curious shift occurred on Earth. NASA's Deep Space Network, which had long shared mission updates publicly, began delaying or redacting reports. Mission logs, once detailed and accessible, were replaced with vague summaries. Engineers, previously vocal on platforms like X, fell silent. Press-friendly figures at JPL declined interviews, and whispers of closed-door briefings involving entities beyond NASA, agencies tied to national security, began to circulate. The message was clear. Whatever Voyager had encountered was no longer just a scientific curiosity. This opacity fueled a wave of speculation. Independent researchers, leveraging open-source data and AI tools, proposed theories. Some attributed the gravitational anomaly to a pocket of condensed dark matter, an uncharted cluster dense enough to bend Voyager's path. Others suggested the 3 kilohertz signal was a relic of a primordial cosmic event, an echo from the Big Bang caught in a rare alignment. More radical voices, including a fringe group of astrophysicists, posited that the signal was artificial, a beacon activated by Voyager's presence. They pointed to forgotten anomalies from Pioneer 10 and 11, slight decelerations once dismissed as thermal effects, now reevaluated as early encounters with this same boundary. The most provocative hypothesis came from a small but vocal cohort. Voyager wasn't approaching an object but a response. Its signals, its trajectory, its very existence might have triggered something. A switch in a cosmic machine older than humanity. This idea, while speculative, resonated with a growing unease. In 2025, advancements in quantum field theory and string theory have begun to suggest that space itself may possess emergent properties, behaving like a system with rules, limits, and perhaps even agency. If true, Voyager's data could be the first evidence of a universe that doesn't just exist, but reacts. A paradigm shift. Voyager 1's journey has always been a story of boundaries pushed, Earth to the moon to Mars, Mars to the heliopause. We've seen space as a passive canvas, a vast emptiness awaiting our exploration. But these findings shatter that illusion. If the edge of our solar system is alive, pulsing with signals and forces that defy explanation, then the universe is not a playground, but a system. Like any system, it may have parameters, boundaries, and, most unsettlingly, guardians. The emotional weight of this discovery is profound. Voyager 1, a relic of 1970s optimism, was never meant to return such data. It was a goodbye letter to the stars, a gesture of hope. Yet, it has become something more, a messenger bearing consequence. Its low-frequency hum, its gravitational drift, its chaotic plasma readings. They are not just data points, but clues that the cosmos may be watching. The silence from NASA, the redacted logs, the hushed briefings, they suggest that this realization has reached beyond science into the realm of existential policy. In 2025, humanity stands at a crossroads. Advances in AI, quantum computing, and space exploration have accelerated our reach. From SpaceX's Starship missions to the Artemis program's lunar ambitions. Yet, Voyager's whisper reminds us of our limits. The universe, once a frontier, now feels like a territory, one that may not welcome trespassers. On platforms like X, discussions rage, blending science, philosophy, and fear. Some call for bolder exploration, urging new probes to follow Voyager's path. Others caution restraint, citing the unknown risks of provoking a response. The question we cannot ignore. Voyager 1 was never meant to return like this. It was a relic, a fading echo of human ambition. Yet, against all odds, it spoke one last time, and its message was not one of triumph, but of warning. The 3 kilohertz signal, the gravitational anomaly, the turbulent heliopause, they challenge our assumptions, forcing us to confront a question as old as exploration itself. What lies beyond the known, and are we ready to face it? If Voyager is being pulled, if its path is no longer governed by physics alone, then the darkness beyond our solar system is not just space, it's something more. The silence we've heard from the cosmos may not be emptiness, but restraint, a pause before a response. Voyager, our quiet hero, may have done more than observe the void. It may have been seen by it. And now, we must ask, was sending it out there a mistake? The universe is no longer a blank canvas. It is a system, alive with forces older than time, perhaps even aware of our presence. Voyager 1's final whisper echoes louder than any signal, urging us to decide, do we press forward, chasing the next whisper from the void? Or do we pause, recognizing that some thresholds were never meant to be crossed? The choice is ours, but the cosmos is watching.